If this one glacier were to melt completely, it alone would add 1.5 meters, or nearly 5 feet, to the world's sea level.
An ice sheet is defined as a mass of glacial land ice extending over more than 50,000 square kilometres, or 20,000 square miles. There are only 2 ice sheets on Earth today. Between them, they contain approximately 99% of all the Earth's ice. Antarctica is nearly twice the size of the 48 contiguous states of the USA. It holds approximately 90% of all the Earth's ice, which in turn represents 60 to 70% of all the Earth's fresh water. To put this in context, if the Antarctic were to melt overnight, global sea level would rise by 60 meters, or 200 feet. Greenland is 3 times the size of Texas and contains approximately 9% of the Earth's ice. And the rest of the Earth's ice combined amounts to just 1/10 of Greenland's ice. As snow falls from the sky, it brings with it dust, volcanic ash, radioactive materials, bubbles of atmospheric gas, in fact just about anything that's in the atmosphere at the time. Ice sheets are formed by the accumulation of falling snow and the effects of gravity. In this simple diagram of an ice sheet, you will see that the ice flows away from the summit of the ice sheet. As a result, ice accumulation in the glaciers, the flowing ice, may be greater because the snowfall from a wider area contributes to the glacier, whilst the ice at the summit is less prone to flowing. Ideally, ice cores are therefore taken from ice sheet summits, where gravity is acting downwards and there is little ice sheet flow sideways. The snow which falls passes through stages before becoming ice. Initially, the snowflakes are compacted and transform into firn, which is grainy, looking like granulated sugar. The firn is full of air gaps or pockets. As snow layers fall above, the firn is compacted. There comes a point where the compaction closes off these air gaps, and the air is sealed into that layer. Prior to this point, the air can circulate between layers, and the age of the air trapped in a layer is therefore not the same as the age of the ice in that layer. The trick for the scientists is to be able to identify layers in the ice cores and then date these layers. Now, why do scientists spend so much time and effort, and governments spend so much money, extracting these ice cores from the most inhospitable locations on the planet? It's difficult to get figures, but Nature magazine reported in April 2008 that the US National Science Foundation alone was spending $325 million in Antarctic research and $100 million in the Arctic. Do they do it as part of some conspiracy to prove the Bible is scientifically inaccurate? Do they know that all the information they provide about ice cores is wrong? Do all these scientists simply not know what they are doing? Are they all mistaken in their interpretation of the data they collect? Or are they perhaps doing it because they know that the most effective way to understand the mechanisms involved in Earth's climate is to understand the historic or paleoclimate, and the best way to understand the paleoclimate includes drilling and examining ice cores? Often in life you will find that motive is everything. So if you find someone telling you that all these scientists on the Antarctic and Greenland ice sheets are part of some atheist conspiracy, ask yourself, what is the scientist's motivation? But also ask yourself, what is the motivation of the person who is trying to convince you that there is a conspiracy? And so too the science. After James Chadwick proved the discovery of the neutron in 1932, it became accepted that the atomic nucleus consisted of protons and neutrons. The isotopes of any chemical element differ in that they have the same number of protons in the nucleus, but differing numbers of neutrons. Chadwick's discovery therefore proved instrumental in progressing the study of isotopes. Harold Urey won the Nobel Prize in 1934 for a discovery he made in 1931. He was a pioneer in the area of chemical isotopes. In 1931 he discovered deuterium, also known as heavy hydrogen. The common isotope of hydrogen, also known as protium, has a single proton in its nucleus. The deuterium isotope of hydrogen has a proton and neutron in its nucleus. It was the discovery of the neutron in 1932 which made the structure of the isotope he'd discovered in 1931 now very obvious to Urey. In the November 5th, 1948 issue of Science magazine, Urey published a paper titled Oxygen Isotopes in Nature and in the Laboratory, in which he detailed the way that the ratio of oxygen isotopes might be used to calculate the past temperatures of the Earth's oceans. Now, in 1954, Willy Dansgaard published a paper in the peer-reviewed journal Geochimica e Cosmochimica Acta, showing how the abundance of oxygen-18, a stable isotope of oxygen with 2 additional neutrons, varied in fresh water, dependent on several factors, including temperature. In the late 50s, the US Army decided to dig 2,500 miles of tunnels under the Greenland ice sheet, as you do. Now, they didn't bother mentioning this to Denmark at the time, of course, because they wanted the 600 nuclear missiles they planned to deploy there to remain a secret. In the end, they dug just 2 miles of tunnels, complete with church, hospital and theatre, before Project Iceworm, as it was called, was cancelled when the army realised that the glacier they were digging into was moving too fast and the tunnels would not survive. Now, the cover for the operation was that the army was carrying out studies on the feasibility of army operations on ice caps. But one non-classified product of the operation was the Camp Century Ice Core, a 4,600-foot core drilled to look at the state of the ice. Now, this core was thought to represent 100,000 years of snowfall on Greenland, and Willy Dansgaard realised that by measuring the oxygen-18 levels in the core, he should be able to reconstruct historic atmospheric temperatures. And that was the beginning of ice core science. Scientists have now had half a century to refine dating techniques. Accuracy of scientific instruments has increased dramatically. Computers have allowed for vast sets of data to be crunched and cross-referenced where once all the work had to be carried out manually. More and more ice cores have been drilled for cross-referencing, and accuracies continue to improve in various radiometric dating techniques, dendrochronology, lake sedimentation, etc., which all adds to the accuracy of those techniques and also the accuracy of cross-dating between the various disciplines. So, how does ice core dating take place today? I should first repeat that a single ice core is dated using the appropriate techniques. The results from these techniques are cross-matched to ensure they agree. An ice core can then be cross-matched with other ice cores and other dating proxies such as sediment cores by synchronizing them on unambiguous climate events such as major volcanic eruptions. Be clear that it is only when cores are cross-matched to a high degree of certainty that any results are published. Now, each snowstorm will leave a distinct layer. The top of each summer layer can often be distinguished by a sharp surface or melt layer, and annual layers can often be distinguished in this way to a certain depth, but the accuracy diminishes as the snow is compacted to glacial ice. The ratio of oxygen-18 and deuterium isotopes is dependent on the temperature at the time the snow fell. The annual cycle of, for instance, delta O18, that is the change in oxygen-18 levels, is a clear indicator and correlates well with observed temperatures in recorded history. The core is sampled many thousands of times to measure the delta O18, and this provides accurate dating of annual layers. There are 2 important points to be made. The first is that, again, this dating method is limited to the top of the core. As the ice becomes compacted under gravity, diffusion of the O18 prevents accurate dating, and this currently limits stable isotope dating in Greenland to about 8,500 years before present, i.e. before 1950. The second problem was mentioned earlier on this video. When the snow first falls, and before it's compacted sufficiently and seals the air bubbles in place, the air is free to move to some extent. This can reduce the ability to differentiate the annual layers. Provided annual snowfall is sufficient, this isn't a problem. Dating using impurities. Anything that is cyclic in nature can be used to date an ice core. Calcium, sodium, nitrates and ammonium all appear in the ice core. Continuous flow analysis is able to detect contamination equivalent to a pinch of salt in an Olympic-sized swimming pool. And the following are tested for: the amount of insoluble dust and the size distribution of the particles, concentrations of various chemicals, and the conductivity of the meltwater. Synchronization of ice cores. A single ice core will only provide a certain level of confidence when dating. By dating multiple ice cores independently and then cross-matching them, a much higher degree of confidence is achieved. To achieve this requires reference horizons. These are specific markers that can be seen across ice cores, allowing those ice cores to be tied together. Volcanic eruptions, for instance, leave a chemical fingerprint in the ice. The fingerprint can be unique enough to identify not only the source volcano, but the specific eruption of that volcano which produces the ash. Two ice cores can thus be cross-matched by lining up ash layers which have the same chemical fingerprint. Methane levels in the atmosphere vary with time, sometimes abruptly. Because methane is well mixed within the atmosphere, the sharp variations in methane levels are recorded globally and can be used to match ice cores from different sites, including between Antarctica and Greenland. Beryllium-10 is created in the atmosphere by the action of high-energy cosmic rays. The rate at which it is created is affected by solar cycles and the strength of the Earth's magnetic field. Because of the cyclic and global nature of the beryllium-10, it is very useful for linking ice cores again between Greenland and Antarctica. Peaks in the impurity data can also be used to synchronize cores. One way to achieve this is to measure the precise conductivity of the core at thousands of positions and match this up against the conductivity profile of a second core. I hope you'll see that there are multiple measuring tools available for the scientists, all of which can be used to cross-validate each other. There is a margin of error, but it's a margin only. A few hundreds of years over many thousands of years. So, what do creationists say about ice cores? Bear in mind that they claim a global flood took place around 4,500 years ago. This is important because if ice cores can be reliably dated back to, say, 5,000 years ago, that's all. The biblical global flood cannot have taken place. 5,000 years. That's how far we have to get back. Creationists do attack the annual ring dating of ice cores. Here is a quote, often repeated. My mistake. I should have said, here is a quote, mine, often repeated. This is taken from the visual stratigraphic dating of the GISP2 ice core, etc. The paper is discussing the issue of accurate visible dating of the ice core, and it unambiguously states that there is a high accuracy in dating of 1% error for Holocene dates and 5% error for Wisconsin dates. Now, Wisconsin are 40 to 50,000 years BP. The GISP2 ice core dates back to 120,000 years, and the paper was concerned with the visual dating of the core deeper than the 50,000 year mark. Well, have I said enough? Probably too much, but bear with me a little bit more while we have a bit of fun with my favourite creationist clown.
There is no formal scientific write-up that I'm aware of, but the facts are clear. There is no formal scientific write-up that I'm aware of,
but the facts are clear.
And you can view photographs and video for yourself and see the hundreds of ice layers visible in the gopher hole. This clearly shows that the assumptions of the ice layers, representing tens of thousands of years, is falsified.
I covered this in a previous video. It would be charitable to say that Ian misconstrued the data, but as he had access to the same data as me, I would say that he chose to interpret the data in a certain way. If he'd simply watched the program, the film, on the Glacier Girl and specifically on the gopher hole, then he would understand that the rings he sees in the ice are all to do with the melting process of a gopher, and that no interpretation about annual layers or seasonal layers can be made because there was no scientific investigation carried out.
Those who believe in deep time believe it takes hundreds to thousands of years to compress snow and ice granules into solid ice. And thus, as Fred Hall wrote way back in 1989, eliminating any possibility of using the presence of such gases to count annual layers over thousands of years.
Ian has provided a reference for us here. In which peer-reviewed journal was climatologist Fred Hall writing in 1989? Ah, I see. Fred wasn't a climatologist. But he was obviously a clever guy, and he got his paper published in a reputable journal. Ah, I see. He was writing in Eon. This is a comic for people who follow Velikovsky. I think I'll rest my case there. If you do not know who Velikovsky is, you have some fun reading ahead of you. Thanks for watching.